Hello viewers, today we are going to look at something interesting, that is finding the common root of 2 or 3 quadratic equations. This is the question that we are trying to solve. If the 3 quadratic equations x squared plus ax plus 12 is equal to 0, x squared plus bx plus 15 is equal to 0, and x squared plus x times a plus b plus 36 equal to 0 have one common positive root. Find a, b and the roots of all these equations. That's the question. Now, of course, it's stated that x, a, b, all these are real numbers. That's also a given thing. So we are given that these 3 quadratic equations have one common positive root. Of course, it's a real root as well. Then we are asked to find the values of a, b and the roots of all the 3 equations. An interesting question, isn't it? Let's look at the methodology that we are going to adopt to solve this question. So, we'll take a sneak preview and the basic technique, basic theory required for solving this problem. Let's look at the quadratic equation ax squared plus bx plus c is equal to 0, right? Where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term, right? Now, of course, if a is 0, then we don't have a quadratic. So it's pretty clear that a cannot be 0. So we divide both sides by a, then we end up with this. Right? 0 by a, 0 divided by a, which is going to be 0. This holds water because a cannot be 0. Okay, now let's say alpha and beta are the roots of this equation. Then we could rewrite this as x minus alpha times x minus beta is equal to x squared plus b by a times x plus c by a, which is equal to 0, right? Now we expand this out and then compare the relevant terms. X squared minus alpha plus beta times x plus alpha beta is equal to x squared plus bx by a plus c by a, right? This is equal to 0. Now we compare term by term. It's the coefficient of x squared is the same on either sides. The coefficient of x here it's minus of alpha plus beta, here it's b by a, and the product of the roots is c by a, the constant term. So we match this term by term. We figure that minus of alpha plus beta should equal b by a, and alpha beta should equal c by a. So if we had a quadratic equation of this form, then the sum of its roots would be minus b by a, where b is the coefficient of the x term and a is the coefficient of the x squared term. And the product of the roots, alpha times beta, would be the constant term divided by the coefficient of x squared. So this is the most important result that we need to know to look at this problem. So now we could look at the roots of this equation. Right? Let's say alpha is one root. Then the product of the roots would be 12, right? 12 divided by 1. Because the coefficient of x squared is 1 and the constant term is 12. So the product of the roots, 2 roots of this equation would be 12. So if alpha were one root, the other root would be 12 divided by alpha, right? And the sum of these 2 roots would be alpha plus 12 divided by alpha. That should be equal to minus negative of the coefficient of x divided by the coefficient of x squared. So minus a by 1, which is minus a, right? Let's look at the next equation. X squared plus bx plus 15 is equal to 0. Let's assume that alpha is a common root. There's nothing wrong with that. Then the other root of this equation would be, because the product of the two roots of this equation would be 15 divided by 1, c divided by a, right? The constant term divided by the coefficient of x squared. So if the common root were alpha, then the other root would be 15 divided by alpha, right? And the sum of these two roots would be alpha plus 15 divided by alpha, which according to what we saw just now would be negative of the coefficient of x divided by the coefficient of x squared, which is 1, minus b divided by 1, which is minus b, right? So we have these two equations, and we go to the next one. X squared plus a plus b times x plus 36 is equal to 0. As we have assumed that alpha is the common root, alpha would be one root. Again, the product of the two roots of this quadratic equation would be 36 divided by 1. So the other root would obviously be 36 divided by alpha. And the sum of these two roots would be alpha plus 36 divided by alpha, which should equal negative of the x coefficient divided by the coefficient of x squared term. So which is minus of a plus b divided by 1, which is minus a plus b. So we have three equations here. This is equation number 1, equation number 2, and this is equation number 3. Right? So let's say we want to add 1 and 2, then we would get 2 alpha plus 27 divided by alpha is equal to minus of a plus b, right? This is twice alpha plus 27 by alpha is minus of a plus b. And we compare the right hand sides of these two, that is, let's call this equation number 4. We compare the right hand sides of equations 3 and 4, we find that they are the same, right? So that means we can equate their left hand sides as well. That means twice alpha plus 27 by alpha should equal alpha plus 36 by alpha. This is the left hand side from here. This is the left hand side of equation 4. This is the left hand side of equation 3. Right? So we bring this alpha here. So alpha should be equal to, we take that to the other side. 36 minus 27 is 9 divided by alpha. Or alpha squared is equal to 9, which means alpha is plus or minus 3. Right? And we have assumed that alpha is the common root for all the equations, and the problem states that these three equations have a common positive root. Therefore, alpha cannot be minus 3. Because we are given, we know that alpha is the common root for all the three quadratic equations, and it's been stated in the problem that they have a common positive root. Therefore, we neglect alpha is equal to minus 3 and proceed with alpha is equal to 3. So, equation, let's call this equation A. So, the common root is 3, right? All these three equations, 3 is the common root. The roots of this equation would be alpha, which is 3, and 12 by alpha, 12 by 3, which is 4. So 3 and 4 are the two roots of equation A, right? And then equation B, the two roots will be alpha and 15 by alpha. Alpha is 3 and 15 by 3, which is 5. So 3 and 5. And equation C, which is this one, its roots are alpha and 36 by alpha. Alpha is 3 and the other one would be 36 by 3, which is 12. So the roots are 3 and 12. So this is a nice and neat problem where we found that the common positive root is alpha, which is 3, and the roots of the individual equations are 3 and 4, 3 and 5, and 3 and 12. The other part that we need to look at now is to figure out the values of A and B. From equation 1, we know that alpha plus 12 by alpha is minus A. So let's use that equation. A would be minus of alpha, which is 3, plus 12 by 3, which is 4. So A would be minus 7. And let's use equation 2 to find the value of B. That's b is equal to minus of alpha plus 15 by alpha, which is 5. So this is minus 8. Hope you like this problem. It's a neat and tidy problem. And hope you love the technique that we use to solve this systematically. Please subscribe to our channel and take a look at our previous videos, and also watch out for our upcoming interesting video series. We would like to thank all our subscribers because we just reached the 100 subscriber limit mark. We again thank each and every one of you, our subscribers. Thanks for watching.